Hello children, in this video we will be discussing the simple applications of the refraction. So children, once again refraction means we need to understand what actually optically denser medium, what actually optically rarer medium. Children, the medium in which light travel faster when compared with other medium is called optically rarer, whereas the medium in which light travel slower when compared with other medium is called optically denser medium. And one more thing also we should keep in our mind is that whenever light moves from optically denser medium to rarer medium, it moves away from the normal. Whereas whenever light moves from rarer to denser medium, it moves towards the normal. So these are the two things which we have to remember in order to understand the simple applications of the refraction. Children, apart from that, let us think about kingfisher. What is this kingfisher? Of course, we all know that kingfisher bird is, children. So how it can catch the fish? In order to catch the fish, what it can do? So for some time just it will be flying above that water pond or a lake or a water source, whatever it may be, and it can catch the fish. That we know. Of course, most of the time it is successful in catching the fish only. But children, here we need to think about the 2 points here. The first point is that here the fish will be somewhere else at a depth inside the water. How a kingfisher bird is able to see it is the first question. And the second one is that okay, it has seen somehow, so it is ready to catch the fish. But one more important point is that while the kingfisher bird is catching the fish, what this fish is doing, of course it can escape, right? Why it is not escaping? Children, two parts we need to understand. What is that? How a kingfisher bird is able to catch the fish. That is the first point. The second point is that while as a kingfisher bird is trying to catch the fish, what this fish is doing, why it is not escaping, why it is not trying to escape. So these two things only we are going to discuss. Children, if you want to understand this full concept, we need to understand about the three important terms. What is that? We need to understand real depth, what is apparent depth, and the shift. And one more very important thing is that how refractive index is related to the real depth and apparent depth. How refractive index is related to the real depth and apparent depth. So these four things are very important so that we can understand very easily how a kingfisher bird is able to catch the fish and why a fish is not it's trying to escape. Of course it will try, but why it is not happening like that actually. So this is what actually today's agenda, what are we going to discuss. Children, now let us take a case of here. Children, let us take a case here. So here is, let us say here is a water pond, something like here is completely it is a water, no doubt, fine. Now here is a bird, okay, let us say it is a kingfisher bird, so it is in air only. So this is the first situation. Children, now we will think from the point of view bird. Just think that we are bird. Of course, we won't become bird. Just you think that from the point of view bird we can think. I mean what here? Just you think that here bird is observing the fish. The first case means what here? In the first case, bird is going to be observer, whereas fish is going to be object. Very important. So fish is going to be object, and here bird is an observer. Means for a fish, for a bird, how the fish appears, that we are going to discuss. Children, so first case here, case 1, we will be discussing that here. Object, very important. Here what is our object? Object is a fish, children. So object is in rarer medium. Object is in rarer medium, whereas observer, who is observer here? Observer, that is a bird, kingfisher. So here observer, that is a bird, is in denser medium. This is the first case, children. It's very important. Very important. So first case, object is in denser medium, observer in rarer medium. Here observer is, who is observer here? Bird. Bird is observing this time. For a bird, how the fish appears, that is what we are going to discuss. Fine, children. Now look at here. As a bird, that is as a fish, it is an object. It is placed in a denser medium. Now light rays from this object, that is the fish, will go from all directions, downwards, three-dimensionally it will go. But here we will consider the light rays towards the observer. Just you think that now bird is observing that fish, vertically, from top it is observing. So here what will happen, look at here, let us consider two light rays. Let us draw the two light rays from the object. One is coming vertical, that is normal to this interface between the two mediums. Another one is the second light ray is considered here. Now what will happen to the first light ray, dear children? As it is incidenting normally, what will happen? It will go undeviated. So this light ray, dear children, it will go undeviated, means like this it will go, like this. So it will go undeviated. Okay. But what about the second light ray, dear children? Here, as it is not a normal incidence, what we have to do? Just let us make a normal. And just one very important thing which we know, that whenever light is moving from water to air, that is denser to rarer, what happens? It moves away from the normal. So children, this light ray moves away from the normal. So this is how actually light ray is getting refracted. But dear children, do you think that these two light rays are able to meet? Of course, they don't meet. Then what we have to do? We have to extend the refracted light rays back. So let us extend this light ray back. So this is a point where image of the fish is appears to be formed. Image of the fish is formed at this point. So let us make here. So fish image, children. It is not a fish here. Simply it is a fish image is formed. Fish image. Let us say it is an image. Fish image is formed. Means what here? For a bird, children, for a bird which is observing from the rarer medium, this fish appears. Actually, it is at this point only. But for that bird, it appears very close to the water surface. Which means what here? For a bird, the fish is appearing very, very close. Actually, it is not. But due to the refraction here, what is happening? It is appearing. It appears as if it is raised. So what will happen? A bird will get tempted. So then it will try to. Means as a bird is coming closer to the water, more close it appears. As it is coming more closer it appears. So that is how actually fish appears to the bird. Very, very important. So that is the reason why actually bird will try to catch the fish. So it's very important. Here bird is observer, placed in a rarer medium. Fish is object, placed in a denser medium. Now here, as I told, the three important words are very important. What is that? Apparent depth, real depth, shift. And how these three are related also very, very important. Now dear children, if you can see here, the depth at which actually fish is there, is called real depth. Children, very, very, very important. The depth at which actually fish is there, is called actually real depth. What is the real depth? Actually the object at what depth it is placed is called real depth. But dear children, but for a fish, how is it appearing? It is appearing as if it is raised. For this bird, fish appears at this point. So this is called this depth at which image is formed. The depth at which image is formed. Is called apparent depth. Children, apparent depth means what? Not true. It is not true. Try to understand. So the depth at which image is formed is called apparent depth. So here what is happening? The bird image is shifting from original position to this position. So from here to here, we can call it as a shift. This is SHIFT, shift. So children, try to understand here. What is a real depth? The depth at which object is situated is called actually real depth. What is actually apparent depth? The depth at which image is formed. Is called apparent depth. What about shift, dear children? The distance through which the image is raised is called shift. Now we will see how these three are related. Children, it's very simple. So how can we write the relation? Look at here. So very clear that, dear children, here real depth is equal to, it can be written, real depth is equal to, we can write it is a apparent depth plus shift. Am I clear? So this is how actually we can calculate. So in order to calculate the shift, dear children, so here shift is equal to real depth minus apparent depth. Children, it's a very important formula. Means whenever real depth and apparent depth is given, this is a formula which we use to calculate the shift. Shift is equal to real depth minus apparent depth. Children, it's very important. Children, so whenever real depth and apparent depth is given, how to calculate the shift? So that is shift is equal to, dear children, real depth minus apparent depth. So here what is happening, dear children, due to the refraction actually, so this is the where actual object is, fish is there, but it is appearing as if it is shifted vertically upwards. Just it is happening because of refraction. So here shift is equal to real depth minus apparent depth. Dear children, in this case, how can we define the refractive index? Of course, refractive index already regarding refractive index in the previous sessions which we discussed. That is, refractive index is defined as the ratio of speed of light in air to the speed of light in a medium, and it also defined as the ratio of sine of angle of incidence to the sine of angle of refraction. But dear children, in terms of real depth and apparent depth, how can we define the refractive index? How refractive index is related to the real depth and apparent depth is very important. But here we have to notice very important thing. What is that? This is a case where object is placed in a rarer medium, observer is placed in a rarer medium. Try to understand. So object is placed in a denser medium, whereas observer is placed in a rarer medium. In this case, how can we define the refractive index? How refractive index is related to the real depth and apparent depth? Children, look at here. So here real depth DL, real depth is equal to, we can write as a refractive index into apparent depth, or we also can write as that ratio of real depth and apparent depth is equal to the refractive index. Children, this is very important. That is, refractive index is equal to real depth by apparent depth. So if you know the real depth, if you know the apparent depth, you can calculate the refractive index of the denser medium with respect to the rarer medium. Children, now as it is refractive index is equal to real depth by apparent depth, from this can we write like this, apparent depth is equal to real depth by mu? Of course we can write. So let it be first equation, and here is a second equation. Now children, let us substitute second equation in first equation. Now shift is equal to real depth minus, in the place of apparent depth we are going to write real depth by refractive index. That is real depth by refractive index. Here refractive index can be taken as a common. So children, here shift is equal to real depth you can take as a common. So 1 minus 1 by mu. So children, this is the one more very important relation which we will be using to solve the numericals. Means this is how shift, real depth and refractive index depends. How they are related is very important. Means by knowing the refractive index, by knowing the real depth, we can calculate the shift. This is a very important. Children, am I clear? So here what we have to understand, what is the real depth? What is the real depth actually? The depth at which object is placed, object is situation. In this case here, fish is the object. What is the apparent depth? The depth at which image is formed is called apparent depth. What is the shift? The depth means at what is the height through which it is shifted vertically upwards is called actually shift. But mathematically, how can we say that here the image of the fish is like a formed at a very lower height, lower depth when we compare with the actual depth. How can we? By using mu is equal to real depth and apparent depth we can. How can we do it? Just now I will show you that. Have you copied this? Fine. Now look at here, it's very important. I will show you how. For example, in this case only, in this case as it is a water, for a water refractive index we know that is a 4/3. We know it is a 4/3. For suppose, dear children, let us say the fish is at 40 centimeters depth. Just example, 40 centimeters depth, let us say. So real depth is 40 centimeters. Actually, where the fish is there, exactly 40 centimeters below the water surface. But for a bird, at what depth it appears is important. So look at here. So in this you can substitute here. We can write apparent depth is equal to real depth by mu. So real depth is 40 centimeters by it is 4 by 3. 4 ones are 4 tens are. This 3 will go to the numerator. So it will be 30 centimeters. It will be 30 centimeters. So here what is happening? Actually fish is there at a 40 centimeters depth. But for this bird, it is appearing that at a 30 centimeters depth, which means what here? For a bird, it is appearing very closer to the water surface. So that is how actually here it is appeared to the bird actually. That's what the bird will get tempted and will try to catch the fish. So children, this is one case where we are thinking from actually bird side. But now what is our question? Okay sir, here bird is trying to catch the fish. Okay, that is okay. But when the bird is trying to catch the fish, what this fish is doing? Which means what? We have to think. For a fish which is in the water, how does a bird appear? This is very important. So now let us think from the point of view of fish we will discuss. Okay children. So this is the first case where object is in rarer medium and observer in denser medium. Now as we are going to think from the what inside of fish, now fish is going to be observed. I mean fish is going to observe the fish is going to observe the bird actually. So here bird is going to be object. So which means what here? We have to change this case. Case 2, what is going to be happen? So here observer. Look at here. Here is observer. That is fish. Observer is in denser medium. Whereas object that is a bird. Is in rarer medium. It's very important. In a previous case, observer in rarer medium, object is in denser medium. But in this case, dear children, here object is in rarer medium, whereas observer in denser medium. In this case, dear children, how can we define the refractive index? So you can't say that sir mu is equal to real depth by apparent. No, that is applicable only in the first case only. In this case especially, refractive index is defined as apparent depth by real depth. Children, it's very important. It is case 2. So in a case 1, it is quite reverse. In a case 1, where the observer is in rarer medium, object is in denser medium, but it is quite reverse. So in this case, how can you define mu? Mu is equal to apparent depth by real depth. Now let us consider here is a boundary between the water and this one. So let us say here is a water. So where here is fish is observing from here. Let us say here is a fish. So children, now here fish is going to be observer. Try to understand. Fish is going to be observer. It is placed in a water, that is a denser medium. Whereas bird, let us say here is bird. So children, here bird is going to be object. Where the object is air, that is a rarer medium. So children, always light rays are drawn from the object towards observer. So here bird is going to be object. So from here we need to draw the two light rays. So let it be vertically here somewhere. Exactly. Let us take here. Here is a fish. Fine. So from here, children, let us draw two light rays. So one light ray, let us consider is coming vertically like this. It is coming like this. So the case where some difference should be there, right? So here is, let us say here is bird, that bird something, let us say here is bird, it is okay, fine. And one more light ray, just let us consider here is one more light ray is coming like this. Of course here is a boundary, fine. So here is, let us draw, here is first light ray, here is second light ray. Now what will happen, if you can just look at here, as the first light ray is coming and incidenting vertically, it's a normal incidence. So this first light ray will go undeviated. So this first light ray will go undeviated. It has to go undv. It is fine only. What about second light ray, children? As it is moving from air to water, that is rarer to denser. Already we discussed, whenever light ray moves from rarer to denser medium, it has to move, it will move towards the normal. I mean, it bends towards the normal. So here, let us make a normal. Here, let us make a normal. So this is a normal. So actually, it has to go like this, but it bends. It bends. Children, it is bending. We have taken just less bending case. We have taken less bending. So here, then what happens to children? These two light rays are not meeting. What we have to do? We have to extend back. We have to extend back. So this light ray, let us extend back. Here, let us extend back. And this light ray, look at here. We are extending back. So this is a point where the light rays are appearing to me. Which means what? This is a point where bird image appears. Here, bird image formed. Try to understand. This is bird image. It is bird image. So actually, originally, bird is here, but for this fish, it appears at a greater height. At a greater means, as a bird is approaching the water, this fish, for this fish, it appears as it is going more height, more height, more height. So what happens? Our fish will be so relaxed. Let the bird come, then I can escape. That is how actually bird thinks. But for a bird, how the fish appears? More close, more close, more close. For a fish, how the bird appears? More far, more far, more far. Just imagine these two things will happen simultaneously. These two things will happen simultaneously. So that is the reason bird will get tempted to catch the fish. Why? It is appearing very, very close. And the fish will be so relaxed. Why? Because it is more far, more far, more far. So it will think, let the bird come so that I have a time to escape. So this is what actually happened just because of refraction. Just because of. So light is undergoing refraction phenomena. So that only for a fish, bird is appearing at a greater heights. Whereas for a bird, fish appearing very, very, very closer. Very means very much closer. See children, in this case, dear children, so this is a height where actually bird is there. Is actually real depth. Is a real depth from here. But that height or a depth at which its image is formed is actually real depth. Now mathematically also we can calculate, we can try here. So here we know that refractive index of water is 4/3 children. Let us say bird is at, for example, 80 centimeters height. 8 centimeters or else 80 meters height. Or else it is okay, 80 centimeters fine. Let us just simple case we are taking 80 centimeters. Actually, above the water, it is exactly at a 80 centimeters height. But for a fish, where it is appearing actually, look at here. So in this case, dear children, so here real depth is given, that is 80 centimeters. Now let us calculate here apparent depth. So here apparent depth is equal to mu into real depth. So mu value is given 4/3. This is 80. Achha, instead of 80, let us take 90. So that our calculation will become more easy. Okay, now fine. So it is 90. So 3 ones are 330. So 4 into 30 it is a 120 centimeters. Try to understand. Means actually the bird is there at a height of 90 centimeters only. But for the fish, it appears 120 centimeters. It appears 120 centimeters. So this is why actually bird will be so relaxed. So this is what actually happens. It's a very simple example to understand. So bird is actually at a 90 centimeters height, but whereas for a fish, it is appearing 120 centimeters. So children, this is what actually happening. This is a story behind the bird and the fish, especially what actually kingfisher bird. Just it is completely based on the concept called refraction of light. Okay, fine. Now we will make the relation between real depth and apparent depth shift. We will make more simple. Let us see here. Now, once again, let us go back to the relation between shift real depth and apparent depth. Shift real depth. Children, this is what actually we got. The final expression which we got, shift is equal to we got real depth into 1 minus 1 by mu. So children, how this formula is modified for a water, for a glass? In a simple format, let us see here children. For suppose, if the denser medium is water, how the shift formula is modified? If the denser medium is a glass, how the shift formula is modified? Children, we know that for a water, refractive index is equal to 4 by 3, whereas for a glass, the refractive index is equal to 3 by 2. Now, let us substitute these values individually. Now, look at here. So, shift is equal to real depth into 1 minus 1 by 4 by 3. So, this is going to be real depth into 1 minus 3 by 4. Let us take LCM, it is real depth into 4 minus 3 by 4. So, finally, we will get shift is equal to real depth by 4. Means, if the denser medium is water, real depth is given, then how can you calculate the shift? Just divide with 4, directly you get the answer. Fine. Whereas, if the denser medium is a glass, region, look at here. So, here we can add here, shift is equal to real depth into 1 minus 1 by 3 by 2. So, let us simplify this, that is real depth into 1 minus 2 by 3. So, here it is real depth into, let us take LCM, that is 3 minus 2 by 3. So, this is going to be real depth by 3. Children, this is very, very simple. We made a formula to more in a simple format, so that it's very easy to calculate the shift in the case of water and in the case of glass also. So, children, these two are, so here shift is equal to, we can write shift is equal to, that is in the case of water, shift is equal to what we got, it is a real depth by 4, means real depth is divided by with 4, then you can get the shift, whereas here shift is equal to real depth by 3. So, this is how we can, in easy manner we can calculate. Now, we will discuss the factors on which shift depends. It's very, very important to understand. So, here shift depends on mainly it depends on 3 factors. The first point is that it depends on refractive index. So, here how does it depend? Also very, very important. Children, so very clear that here shift is proportional to the refractive index. But how to understand this point? Children, we know this formula, right? Shift is equal to real depth into 1 minus 1 by mu. Children, let us take a case where mu is equal to 2 and mu is equal to 4. Let us take mu value and let us try to calculate the shift actually. And in both cases, let us take real depth is, let us take a 2 centimeters in both cases. So, here let us substitute the values and let us see how the shift will be. So, children, shift is equal to 2 into 1 minus 1 by 2. So, this is going to be 2 into 1 minus, it is 0.5. So, this is going to be 2 into 0.5. So, it is a 1 centimeter. Still, in this case, shift is 1 centimeter, where the refractive index is 2. But whereas in this case also, let us try here. So, shift is equal to real depth is 2, 1 minus 1 by 4. This is going to be 2 into 1 minus 1 by 4 is how much deviation? It is a 0.25. So, this is 2 into 0.75. So, look at here 1.5 shift. So, 1.5 centimeters. So, which case shift is more, teacher? Obviously, in this case shift is more, which means what here? Refractive index is more. So, very, very, very important to understand. So, as the refractive index of the denser medium is more, obviously the shift will be more. Whereas the refractive index is less, obviously the shift will be less. So, we can say that shift is directly proportional. Shift is directly proportional to the refractive index. I mean, more the refractive index of the denser medium, more the shift. Less the refractive index of the denser medium, less the shift will be. So, this is the first point. Now, the second thing is that, children, thickness, that is thickness of the denser medium, that is real depth. That is real depth. Thickness means real depth. So how to understand this? Children, let us take a case here. For example, let us take two cases where the denser medium is water only. The denser medium is water, and here also let us take it as the water, which means what? The refractive index is same. The refractive index is same. So here let us say the object is placed at this point. So that this depth is 40 centimeters. 40 centimeters. Whereas in this case, dear children, the object is placed whereas the depth is 80 centimeters. Means this is real depth in this case, and here is a real depth. In both cases, we know that refractive index is 3/2 only. Refractive index is 3/2 only. Now let us calculate in which case shift is more, so that we can understand how shift depends on the refractive index. So let us take here shift is equal to formula. Shift is equal to, we know that children directly we can use a formula. So whenever denser medium is water, we can use shift is equal to real depth by 4. Real depth by 4. That is, we know that it is real depth by 4. So that is 40 by 4. So in this case it is 10 centimeters. So in this case we got shift as a 10 centimeters. Now let us calculate in this case, dear children. That is here shift is equal to real depth by 4. That is 80 by 4, dear children. So here we got 20 centimeters. So shift is equal to 20 centimeters. Now look at here. In which case shift is more? In which case shift is more? In the second case only. Which means what? In both cases medium is same, density, that is the refractive index same. But what makes the difference? Real depth. Real depth, that is the thickness of the denser medium. So more the thickness of the denser medium, more the shift. Less the thickness of the denser medium, less the shift. So how now just you think about the shift depends on the denser medium, that is thickness of the denser medium, proportional to each other. That is shift is proportional to the thickness of the denser medium. So here thickness we will represent with the letter T. We will represent with the letter T. This is the second factor. Now dear children, the third factor is that wavelength. The third factor is that wavelength or color of light. Wavelength or color of light. So how does it depend? So children, if you want to understand this, first let us think about the relationship between what we can say wavelength and refractive index. Children, we know that here wavelength is inversely proportional to the refractive index, and whereas refractive, how refractive index is related to the shift? We know that shift is proportional to the refractive index. So here we can write it is 1 by shift. 1 by shift. So try to understand. Means here refractive index is proportional to the shift, but whereas wavelength is inversely proportional to the refractive index. So we can make a relation between these two. So how wavelength is related to the shift? Inversely proportional. So we can write here shift is inversely proportional to the wavelength. Shift is inversely proportional to wavelength, which means what here? More the wavelength, less the shift, or else less the wavelength, more the shift. Children, now based on this only we can say for which color of white light will show more shift. Children, we know that here wavelength of red color is greater than that of the wavelength of the violet color, which means what? For red color wavelength is more. Try to understand. So for red color as a wavelength is more, dear children, and is inversely proportional to shift. So shift will be less for a red color. So whereas for violet color wavelength is less, so it will shift more. So we can write like this: shift of violet color is greater than that of the shift of red color. Children, it's a very important point. Very means very much important. For which color shift will be more and why? For violet color shift will be more. Why? Because it has less wavelength. So which color will have least shift, dear children? What we can say out of the 7 colors, red color will have less shift. Why? The reason is that it has more wavelength. Okay children, fine. So these are the factors on which actually shift depends. Now we will see, dear children, apparent, what we can say, apparent depth, apparent bending of a, what we can say, stick or a coin, when a coin is placed in a water, how does it appear? So almost these both are the same concept. What are the concept which we discussed for a fish case actually, when the fish is in the water and a bird is in a air, in that case also same concept we are going to discuss. Now look at it, children. When a coin placed in a water, how does it appear? So let us take here is a container. Let us take here is a container in which here is a water. So here actually coin is placed. This actually coin is placed. So when it is viewed vertically above from this water, how does this coin appears? So from this, dear children, let us take a two light rays which is moving towards. So vertical, it should be incident normally, and here is a one more light ray. Dear children, as the first light ray is incidenting normally, what will happen? It will go undeviated. So it will go undeviated. But whereas second light ray, dear children, so as it is not a normal incidence, and moreover it is moving from water to, let us say here is water and is air. What will happen? It will move away from the normal. So this is how actually it will move away from the normal. But dear children, when you extend this light ray back here, so this is the point where actually image of the coin appeared, image of the coin. So here is actually object is placed. This is image of the coin appeared, means the coin appear as if it is raised. It appears very close to us. So in the case of bird, when the bird is observing from the above that water, for that bird, how does the fish appears? Very close, right? In the same manner, when we are observing from here, for suppose we are observing from here, let us say. So we are observing from here. So for us, it appears very close. It appears very close. The same manner, dear children, let us take the case of stick. So when a stick is placed in a water, when a stick is placed, a pencil is placed, when you place your hand, when you place a leg also, so how does it appear? So same concept, look at here. So let us take it is a water container, and here is water, and let us see here is some pencil is placed, pencil or some stick. So it is not a matter whether pencil, stick or anything. So let us see here is the nib of the pencil. Let us just think. Now, how does it appears actually? So here is the water, children. It is completely filled with the water, and here is the air. So now from here, let us consider the two light rays. Let us consider two light rays from this point. So this is a normal incidence. It is an oblique incidence. This first light ray will go undeviated. This first light ray will go undeviated. This is how it will go. But whereas this second light ray here, so as it is oblique incidence, what will happen? It will move away from the normal. It will move away from the normal. And these two light rays do not meet. So we have to extend back. Look at here. So when we extend back, dear children, look at here. So this is a point where the light rays are meeting. Means this tip of this pencil appear to be formed here. So this is where actually the image of this tip is formed. And other ones, look at here. So and it appears like this. This is how actually it appears. This is how it appears. This is now, look at here. Now you can get that feel you will get. So let us say here is object and here is the image. So when you can see the length of the actual length of the pencil, this one is a very less, and moreover it appears as if it is bending. So these things are happening just because of what, children? Just because of refraction phenomena. Refraction phenomenon, these things are happening. So other than this, what we have applications? We have many other applications. One of the best example is that, children, let us take the case of stars. How do they appear? They appear as if they are twinkling, as if they are blinking actually. But it is not that. They are not blinking. They are giving a light at a constant rate. But just because of atmospheric refraction only, they are appearing as if they are twinkling. And one more thing, as we have seen here, a coin, when placed in a water, appears to be raised. Even, dear children, when you take a glass slab, try to put on some letters, statements, and how that letters appears? Through that glass slab, when you can observe, when you can notice, the letters appears as if they are raised, letters appear as if they are bulged. So it is because of refraction only. Even stick, even when we stand in the swimming pool, dear children, our legs appears very shorter. It appears bending. It appears very bending. And one more thing you might have noticed, especially in every shop, of course, in many shops. I am not saying every shop. So they'll put a lemon in a glass of water, Actually, the layman size seems to be very small only. But the moment when it is placed in a water, dear children, what happens? It appears bigger. Just because of refraction of light only. Just because of refraction of light only. So children, these are the simple applications of refraction. Simple application of refraction. So we can understand simple application of refraction when we can understand what actually real depth, what actually apparent depth, what actually shift, and how real depth is related to the how refractive index is related to the real depth and apparent depth. Okay children, fine. In the next session, we will be discussing about total internal reflection. So especially we will be discussing the case of mirage, looming, and after that we will discuss how the total internal reflection will take place in the case of prisms also. Okay children, thank you so much. All the very best.